we're doing the sum and difference formulas today. So you want to pause the video and write down these 6 formulas right here. And I'm going to write these first 2 a slightly different way. This is how we'll typically see them. Cosine of y. And these cosine ones are cosine So in a typical equation sheet, mathematicians are lazy. We don't like writing all this out. So we'll typically write these sum and difference formulas like this. So these appear in the sign line number 1 here. That's really 2 separate formulas. And what this is saying is, if you have a plus, put a plus here. If you have a minus, put a minus there. But look what happens with the cosine formula. Notice how I got this weird minus plus thing? Top goes with top, bottom goes with bottom. So that says if you have something that looks like cosine of x minus y, that can be rewritten as cosine x cosine y plus sine x sine y. Minus goes with plus. And again, that's just a lazy way to write it out. In this sheet that we were just looking at, I've gone through the trouble of writing both versions. I just want you to be aware of that in case you go Google these formulas. A lot of times you'll see them in this condensed version. Okay, now, how are these used? These are used to build new angles from old angles. For example, I could say, for example, do sine of 15 degrees. I could find that exactly using other unit circle angles. I could go, well, 15, wait a minute, I could get 15 by doing 45 minus 30, because 15 is 45 minus 30. That is not sine of 45 minus sine of 30. You cannot distribute trig functions over addition or subtraction. That's the most common mistake. No, now I got to go to that formula that looked like this, the one that said sine x minus y. And just looking at that formula sheet, that was sine of x cosine of y minus, because that was a minus, cos of x sine of y. So I figure out who my x and y are. X is 45 degrees. Remember, this was a problem on the midterm. Anytime you write an angle in degrees, you have to put the degree symbol. A lot of people made that mistake all over the place. If you're writing an angle in degrees, degrees have units. You have to put a degree symbol. So sine of 45 minus 30. So x is 45, y is 30. So this will equal sine of 45 cosine of 30 degrees minus cosine of 45 degrees sine of 30 degrees. Hey, I know all of these. If I didn't know all of these, this wouldn't have done me any good. I could have written sine of 40 degrees plus 5 degrees. Or, no, that wouldn't give me 15. 20 plus minus 5. 20 minus 5 is 15, but then I'd have a bunch of 20s and 5s here, and I don't know sine of 20. I don't know sine of 5. We're trying to use unit circle angles. So now we just read all these off. Sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Cosine of 45 is root 2 over 2. Sine of 30 is a half. And now just some basic algebra. Root 2 times root 3 would be root 6. And I could squish that together into one fraction if I wanted to. So sine of 15 degrees is that expression there. We could, if we wanted to, go back to our unit circle, the whole thing that's got all our 30s and 45s and 60s on it. I could add in all the 15s if I wanted to now. I can find sine, cosine, tangent of 15s, of all the 15s, every multiple of 15, using the sum and difference formulas. Okay, so let's say we wanted, I don't know, cosine of 105 degrees using sine or using sum and difference formulas. So I have to find two of my unit circle angles that either add up or subtract to 105. Well, let's see, 60 and 45 would do it. $60 plus 45 is 105. So now I go look at my equation sheet for cosine of x plus y. That would be this formula here. I'll write it down. So cosine of x plus y is cos x cos y minus sine x sine y. X here is 45, y is, or sorry, x is 60, y is 45. So this would be cos of 60 degrees, cos 45 degrees minus sine 60, sine 45. Don't forget all your degree symbols. We know all of these, otherwise I wouldn't have picked 60 and 45. I know cosine of 60, that's 1/2. Cos of 45 is root 2 over 2. Sine of 60 is root 3 over 2. So I end up with root 2 minus root 6 all over 4. All of our answers, all the 15s that we could get, all the multiples of 15, all the stuff we can get from adding 30s and 45s and 60s and 45s and whatnot, they're all going to look like this. Basically, they're going to be root 2s and root 6s. Maybe we'll have a minus there and a plus there. Things might change, but we're going to get similar answers for all of these. What if I wanted, let's say cosine of 195 degrees. So we got to figure out two of our unit circles angles that will either add up or subtract to 195. Well, I could do, I don't know, maybe 150 plus 45. That would be one way. Or maybe I could do 210 minus 45. Would that work? No, 240 minus 45. Yeah, that would still give me 195. Either one of those would work. So it doesn't matter, pick one. We should get the same answer either way. So now I'm going to use this one. Cosine of 150 plus 45, using my formula, is cos of the first, cos of the second, minus sine of the first, sine of the second. And now we could just pull out our handy unit circle that we've written in our notes and figure out what each of these are. I don't have these memorized, so I'm going to literally figure them out right in front of you. Well, I know the 45s. That's root 2 over 2, root 2 over 2. But 150 has a reference angle of 30 degrees. Here's 150 degrees. So if I fill in my triangle, I'll get 1 negative root 3 to 2. So cosine of 150 is negative root 3 over 2. Sine of 150 is 1/2. So I get negative root 3 over 2, root 2 over 2, minus 1/2 times root 2 over 2. So I get negative root 6 over 2 minus root 2 or over 4. Sorry, those are over 4.